Next super chat, John Meeks. People give their thoughts. And okay, here we go. So hasn't Lenski's bacterial experiment, Amy, correct me if I'm wrong, did you, James W. and Kent, speak on this issue during the open debate part? I believe so, right? Lenski's experiment?
I'm not sure if we specifically talked about it, but I know that it is an experiment that they have been using where they've been trying to take a single species and to see how much variation they can get out of it. It has been fascinating, and it is part of evolution. And so if they mean falsifies it as in it's true, then yes, just like, COVID-19 falsifies evolution. A speciation event is evolution. You just need selection pressure after that.
Falsify it. It fails to falsify it.
Well, yeah, that's what I was trying to either tweak it. Like I'm trying to, if you're trying to say that it is more evidence of evolution because they do speciate, but there's no point that a bacteria is going to stop being a bacteria forever. So when creationists say they're waiting for like one organism to just give birth to another organism, they are, it's a straw man. I call it the Pokemon evolution fallacy. Like they expect one organism to just start like glowing and then just boom, an egg comes out where it's like a completely different organism than its mother's. But no, it'll always.
So I guess if I could give some thoughts, and then feel free, anyone on the panel, jump in as well. This is a big topic, as many proponents of common descent would certainly look to Lenski's experiment as a pretty solid example of evolution and forward evolution. But from my understanding, Lenski's experiment, after tens of thousands of generations, what they observed were a few interesting adaptive cases or episodes, but it was primarily due to, for example, one of the adaptive episodes had DNA being knocked out of the bacterial species in order that they could replicate faster. And so in that specific environment or medium, the E. coli bacteria could indeed replicate faster, but it was due to the knocking out of pre-existing genes. And so essentially, yeah, the bacterial species, they're losing genes, and it's leading to adaptive episodes, but it's long-term degeneration because they're not going to get those genes back. And if you were to throw those bacterial species into another environment, they would essentially be dead on arrival because they don't have those pre-existing genes that were knocked out prior.
Just to clarify, you're not saying that there is a genetic entropy going on here?
I would argue that the Lenski results is a form of genetic entropy that I would call reductive evolution. If you type in reductive evolution in bacteria, you'll find that bacterial species are well known. It's understood that they lose a lot of genes to adapt. And so it's reductive adaptation, basically. So yes, I would say a form of genetic degeneration. Mark, you were going to say something?
Yeah, I think that's kind of misleading because you're sort of making it sound like the only mutations were sort of DNA being knocked out, and that's not true, especially with the citrate feeding ones that had a 2,900 and something base segment of DNA was duplicated. So that was actually a duplication mutation, not a emission. So that's not 100% true. And there were many differences. In fact, they separated them into 3 different clades. So basically speciation between 3 different groups. I'm not sure if it was speciation, but definitely 3 distinct groups. They had increased cell size in all 12 populations. One had an ecological specialization. Some had balanced polymorphism and simple ecosystems. Like there was a lot of change over this time. But as Amy's saying, if you expect it just to grow legs, that isn't nearly enough time or sort of, anything for that to happen. Also, the problem with this question is that you're sort of saying, well, it's equal to 1 million years of human evolution. Well, the mutation rates aren't the same, and you can't really compare mutation rates in a multicellular creature with mutation rates in a unicellular creature. I don't think that's really a good idea.
Okay, let me respond to a few things there. So firstly, I think it was in 2021 And Dr. Kevin Anderson presented this in a debate with Jackson Wheat on this channel. Sam, you probably remember. There was a paper that came out on Lenski's experiment that these so-called beneficial mutations, they're actually being lost in the population rather than being fixed. And these bacteria in Lenski's experiment, they're becoming lazy. They've lost a pretty large portion of their functional genome size. And so even in light of the gene duplication, there's so many genes that are being lost and knocked out in this environment that what we have is a trade-off, but that trade-off's not sustainable because it's resulting in smaller genome sizes and weaker bacterial species. My understanding of the aerobic citrate digestion by bacteria involved the loss of control of the normal anaerobic citrate digestion. So even if you look to the genotype or the genotypic effects of that so-called beneficial mutation, it is a loss or the degradation of a pre-existing system, in this case, a regulatory system. So yes, we're seeing adaptive episodes, but it's all due to a reduction in genetic content. And so you're not going to get your fish to fisherman by throwing out genes. That's not how you climb Mount Improbable. You're not going to climb up the mountain by taking one step, but then 10 steps backwards, and then another step, and then another 10 steps backwards. That's not how you're going to climb the mountain. Go ahead.
Well, what it was good at illustrating is that variation could go on with the correct environment indefinitely. And that, if there are no factors that we need to tweak, however, if we wanted to artificially push things in some sort of direction, then you start to get into where we're dealing with dogs and other species that we have actually changed genetically. But I don't think that this experiment says it's just like, in my opinion, ERVs, Mark was talking, and like all the biologists
never heard of them, Amy.
Speak of. And I will say, I think this gets spicy, just like I think this experiment gets spicy, because I think what the people of this experiment would tell you is this is a great example of evolution, just like ERVs are a great example of evolution. And so I think that this gets fought within the creationist circles and brought up because it is you gotta go where I guess the hammer and nails are taking us.
Well, Amy, I appreciate those points. Sam, I know you're going to say something, so I'll be quick. I would argue this is not forward evolution. This is not the kind of evolution that's going to take, Amy, as you explained earlier, and I appreciate it. You got a single-celled like organism that evolves into a multi-celled organism, into a fish, amphibian, reptile, mammal, eventually man, right? Well, what we see in this experiment are the elimination of pre-existing systems. We see pre-existing metabolic pathways that were essentially hit with deleterious mutations, or a mutation that deletes part of the chromosome, leading to faster replication. That would be, and here's my analogy, and I'll wrap it up here. That would be like if I wanted temporarily better gas mileage in my car, okay? And so I decided to remove weight off of the car, remove the seats, remove the mirrors, remove whatever I could so the car could go faster temporarily. Well, overall, that's degrading to the car. That's not telling me where the parts of the car came from. It's showing how I'm getting rid of those pre-existing parts. And so that's degenerative. And that's essentially what we're seeing in Lenski's experiment. Mark's smiling. So go ahead, Mark.
Well,
I just got to address this.
Oh, no.
Yeah, sure. Go, Amy.
Well, no, okay, just my final thing on... No, we're talking. Sure. You go. I've been blabbing.
Okay, look. You're describing evolution. Evolution doesn't mean that it won't have parts of it that don't basically get made redundant. Vestigial traits are those things that get changed into something else because they're not needed anymore doing the original function. In fact, we even lose parts of creatures that just aren't needed. Like what you've described is evolution. That taking the seats out of your car, and I mean, I hate to compare biological organisms to cars because they're just nothing alike. You're not breeding cars. It's a bad analogy. But just say you did take your seats out of your cars and stuff. that would make it more fit to survive the purpose that you have for your car. So that is not a degeneration of the creature. You're thinking of this as, well, its original form or its original morphology, that is the best thing for the environment, and it may not be. And that's when things lose traits. Like, for instance, if a mammal like takes to the ocean, it may lose its rear legs, and it's, you know, because they're not necessary anymore. So you've just described evolution, Donnie.
That's
okay, let me respond real quick. Sam, we'll throw it to you after, but I don't want to leave that hanging. So firstly, I don't believe that that is the type of evolution that's going to take your single-celled like organisms into fish, amphibian, reptiles, mammals. Because for that kind of evolution to be true, there has to be a genetic event that demonstrates how you could construct highly complex genetic systems. But beneficial mutations, as I think, Mark, you're demonstrating here, are almost exclusively identified and categorized by their phenotype, right? Their physical characteristics. That's what we're seeing with these bacterial populations in Lenski's experiment. You know, they're able to replicate faster, or the citrate digestion. Okay, this is their phenotype. Mm-hmm. But when we actually look to the genetic systems or their genotypes to see what's really going on under the hood, what we actually see is it's reductive. It's the elimination of pre-existing systems. It is the throwing out or knocking out of pre-existing genes. And so, no, that's not going to take your fish to fisherman. I just want to say this because it's not telling us where these proteins came from. It's not telling us where these regulatory systems came from. With the car analogy, it's not telling us where the seats came from, where the engine came from, where the steering wheel came from. It's just telling us how those pre-existing systems were removed. No, you got to show us how these systems can come about through these kinds of mutations. Go ahead.
Oh, and I just wanted to say that I would be highly surprised if it was the only mutations were ever just from a loss of, as someone would put it before, it's actually a loss of data. It's not information, because information implies a mind. But it's not just a loss of data. It is both. You can have a loss and a gain, and sometimes mutations that have nothing happening at all. And so I just guess would poke
if I could, Amy.
Absolutely.
Well, I'd like to add another point to that.
Okay, go ahead.
Which is
actually, Godzilla Freak, if you could, brother, this will take 10 seconds. So I would say, and then we'll throw it to you, Godzilla Freak. I would say it's not necessarily a matter of loss or gain of information. People can probably tell I try to do my best to not use the word information because things can get kind of complicated there. You know, are we talking about Shannon information? What do we exactly mean when we say loss or gain of information? I think it's more about a mechanism, having a mechanism that can explain the origin of these sophisticated systems found in the cell. But what we find is a lot of these mutations, they're functionally compromising. It's a pre-existing system eliminated for a short-term adaptive episode. Is that necessarily a loss of information? Is it a gain of information? That's a complicated question. But we do know that it's pre-existing genes that are being removed or eliminated. That we do know, and that is reductive. Go ahead.
It also sounds like you were just bringing an irreducible complexity, just at like the tail end, at least something hinting towards that. But
yeah, it did sound a bit.
Well, the point I'd like to make is that if it's the case that the life forms we see today are the results of hundreds of millions of years of evolutionary processes, and they began with less function and today have more function, let's just say that took a really long time, then we would expect there to be sort of an equilibrium between gaining function as a response to a stress and losing function as a response to a stress. So that when we experiment on different life forms, we should find that some life forms are more likely to undergo reductive evolution, others more likely to undergo additive evolution, right? Because there should be this kind of equilibrium where, okay, the total number of functions maybe stays the same, they get shuffled around. There should be this up and down. But instead, that's not what we observe. Rather, in the experiments that we see, it seems to be that the overwhelming quantity of evolutionary mechanisms, of methods to adapt to new environments in order to increase fitness seem to go in that reductive direction. So why is it the case, not just for a particular experiment, but for the sum total of all these different organisms, that they're at a stage where reduction is the way to adapt to the environment, right? Is the optimal way.
Sure. And the claim is that it tends to be more reductive, which is what I think there needs to be evidence of. I think that there is lots of empirical evidence of not just deleterious mutations, but beneficial mutations and mutations that do not affect the organism in any way, shape, or form, negative or positive. And so genetic entropy would actually maybe gain some traction if that was the only thing that we see. However, that doesn't seem to be the case.
Well, no, I'd like to clarify the concept here. I'm not speaking necessarily even of all mutations. I'm specifically, in this case, referring to those mutations that are beneficial. Right? Are the beneficial mutations reductive by nature, additive by nature?